The ratio test without endpoints. Part 1. Recall that a geometric series is one where we multiply by the same thing to get to the next term, and then of course add all the terms together, where this series will converge if the ratio is between -1 and 1. Let's consider a different series that's not necessarily geometric, but perhaps way out at infinity, this series does have a ratio. So the first finite number of terms might not have a ratio, but way out where it matters, if I take the nth plus 1 term and divide it by the nth term, perhaps we do get a ratio. If so, that series will act almost exactly like a geometric series. That is, if this ratio, at infinity of course, if it is between -1 and 1, we know that the series will converge, just like a geometric series does. Because where it matters, it acts like a geometric series. Now, weigh it out in infinity if the ratio is bigger than 1 or less than 1, then just like a geometric series, that series will diverge as well. The difference becomes, what if we get this ratio, which equals 1 or -1? In this case, we don't know what happens. And this is called the ratio test, because it tries to mimic a geometric series, or the geometric series test, way out at infinity where it matters. Let's take a look at an example. Suppose that we have the series, the sum from 0 to infinity, of 2 to the n over n plus 1 times 3 to the n. Now, if it was 2 to the n over 3 to the n, then that would be a geometric series whose ratio is 2/3. But we have this extra n plus 1. So what we'll do is we'll use the ratio test, which says, let's look way out at infinity and see if there's a ratio of the terms in the sequence. A sub n plus 1 over a sub n. Which means, let's start by plugging n plus 1 in for every n value, which gives us 2 to the n plus 1 over n plus 2 times 3 to the n plus 1, and then divided by the nth term. Now, when you divide fractions, you can instead flip and multiply them. So dividing by a sub n is the same as multiplying by the reciprocal of a sub n, which gives us n plus 1 times 3 to the n over 2 to the n. Now let's simplify things to the limit as n goes to infinity, and we can match like terms together. So if I match the n plus 1 with the n plus 2, as n goes to infinity, that part goes to 1. If I put together the 2 to the n plus 1 with the 2 to the n, I'm left with 2 on top. I'll show over here on the side. 2 to the n plus 1 over 2 to the n is 2 to the n times 2 to the 1 over 2 to the n, and of course we're left with 2. and now I compare the 3 to the n with the 3 to the n plus 1, I end up with 3 on the bottom. There are no n's left over, so I know that the ratio is 2/3. Kind of like a perfect geometric series. And since this ratio is between -1 and 1, I know that by the ratio test, the series converges. One more quick example. We will look at the series n equals 0 to infinity of n factorial over 10 to the 2n plus 1. There are a few clues that tell me that I need to do the ratio test to find whether or not a series converges. I look for a few things. Anytime I have a factorial, I think ratio test. Anytime I have a combination of functions like exponential with polynomial or polynomial with factorial, although that's already a clue, but anytime I have a combination of types of functions, I think ratio test. So let's do the ratio test, which says let's do the limit as n goes to infinity of the n plus 1 term, so n plus 1 factorial, over 2 to the 2n plus 3. Let me show you where that comes from. I get 2 times quantity n plus 1, which of course gives me 2n plus 3. And then divided by the nth term, but instead we will flip and multiply to get what we want. We can now simplify like terms. So if I put the 10 to the 2n plus 1 over 10 to the 2n plus 3, I get 1 over 100. But if I get n plus 1 factorial over n factorial, well, that leaves me with an n plus 1 on top. And since we have an n left over, we can plug n, quote unquote, equals infinity, which means my ratio goes to infinity. So way out in infinity where it matters, the series acts like a geometric series with a ratio of infinity, which of course means by the ratio test, the series diverges because infinity is much greater than 1.